Hey everyone, welcome to another calculus video. This is section 3.7, the chain rule. This is part 1. Alright, and this is mainly going to be concepts. There'll be a second video, part 2 will be just lots of examples. Okay, but the conceptual part's very important, and there's a couple of problems included in here as well. So here's the idea with the chain rule. Okay, let's say we want to take the derivative of x to the third plus 2x to the second, all right, all to the second. Well, the power rule tells us what? The power rule says you're supposed to bring down the 2 and subtract 1 from the power. That's what the power rule says. And so maybe that's enough, but it's not. And the reason it's not enough is the same reason you can't just multiply the two things in the product rule, because this is what? This is x is also, and so as x changes, not only does the big square change, but these little pieces change also. Okay? So what exactly does that mean for us? What it means for us is that we need to think about this in a slightly different way. So what does a square mean? A square means that we multiply it by itself. And so let's use the product rule on this product and see what we should get. So we have the derivative of the first, 3x squared plus 4x, times the second, x cubed plus 2x squared, plus the first, x cubed plus 2x squared, times the derivative of the second, which is again 3x squared plus 4x. So we have what? We have 2 of these terms, x cubed plus 2x squared to the first. So we did get this part, but then there was extra. There was 3x squared plus 4x. And where is that? What is that? That is the derivative of the inner part of the function. Okay, so the idea of the chain rule is that this function is really made up of two smaller functions, or a composition of functions. That's the idea. So if y is equal to f of u and u is equal to g of x, and both of these are differentiable functions, then when you go to take the derivative of f of g of x, one function inside of another one, then you can compute the derivative in two different ways. You can think of it using Leibniz notation, where you find dy dx by finding dy du and du dx, or you can take the derivative of f of g of x by taking the derivative of the outer function. The inside stuff stays the same, and then you multiply by the derivative of the inside function. Okay, so if we do that same example again, where we have y is equal to x cubed plus 2x squared all squared, what's playing the role of g? The inside function, g of x, is this stuff, x cubed plus 2x squared. That's your u. And so another way to think of this then is that y is equal to u squared, and then over here, u is equal to x cubed plus 2x squared. So when you differentiate, you take dy du. What's the derivative of u squared? It's just 2u to the first. And then what's the derivative of u with respect to x? It's 3x squared plus 4x. And so now, according to this, we're supposed to find dy du, we're supposed to multiply them together. And if we multiply these together to get dy dx is dy du times du dx. And so we just end up with what we found before. We have 2u times 3x squared plus 4x, but then of course it's not about u, so we got to plug this back in for u. It's 2 times the group x cubed plus 2x squared, that's the u, and then that's times 3x squared plus 4x. Okay? So what happens is we do one rule at a time, and that is the key to being successful with the chain rule. You do one rule at a time. Okay? So let's pause the video here and let you try to find dy dx for the function y equals sine of x all cubed. Okay, so sometimes we could write it as sine with a little 3 up top, but I'm not going to do that right now. We're going to write sine of x all cubed. I want you to take a minute, pause the video, and try this out, and come back and I'll show you how to do it. Okay, so playing the role of u is the inside function sine of x, and so we get y is equal to u cubed, and u is equal to sine of x, and so dy du is 3u squared. What about the derivative of sine? We just did this the other day. The derivative of sine is cosine, and so we take these two guys and we put them together to get dy dx is the product of these two. So we get 3u squared cosine of x, and of course I don't want u in there, so you want to plug in sine, 3 sine squared cosine of x, and that is the derivative, the first derivative of sine x cubed. It's 3 sine x squared times the derivative of the inside function, which is cosine of x. Okay? So when you're using the chain rule, you want to identify what the outer function is and the inner function, and let u be the inner function. That's what I was doing, right? And then you want to think of y in terms of u, and then you calculate each individually and you find the product. Okay, so that's just what we've been doing. Now you can also do it with regular numbers. Okay, so let's take a look at this tabularly defined function. I can't say that again, so don't ask me to. The functions are defined in a table. Here is information about f prime of x, g of x, and g prime of x. And we're told what happens when x is equal to 1 and when x is equal to 2, and that's it. That's all we have. So we want to find the derivative of f composed with g. Another way to write it would be using Leibniz operator notation. We want to take the derivative of f of g of x, but then we want to evaluate it when x is equal to 1. Okay, so how are we going to do that? Well, what's the derivative of f of stuff? It's the derivative of f evaluated at g, and plug a 1 in for x. But then you have to multiply by g evaluated at 1. So here's f prime of g of 1, and here's g prime of 1. Now we go to our table. F prime of g of 1. What's g of 1? When x is equal to 1, g is equal to 2. So this is f prime of 2 times g prime of 1. And now we can take a look again. F prime at 2 is 7. G prime at 1 is 3. And so 7 times 3 is 21. Okay, so you should be able to do this type of process with a tabular defined function or a graphically defined function. Why don't you try this guy, f of g prime of 2 now. The only difference so here is that I'm changing from x equal 1 to x equal 2. See if you can figure that out. Okay, so again we're taking the derivative with respect to x of f of g of x evaluated at x equal 2, or you could just jump into it and say this is f prime of g of 2 times g prime of 2, and now start to evaluate. G of 2, when x is equal to 2, g is equal to 1, and g prime of 2, and so we get f prime of 1, f prime of 1 is 5, g prime of 2 is 4, so we have 5 times 4, which is 20. All right? So that's a basic introduction to the chain rule. We're going to have a second part. The second part video will be me doing about 5 or 6 different types of examples with you having opportunities to do some as well. Okay? So tune in for that next.